Good day, how are you? Today's class is going to be about angles. Here are the class objectives. Take a moment and read through them. Also, this is the new vocabulary words. You might want to write them down and jot down the definition. Okay, the first one is we have to define what is an angle. Well, an angle is two rays with a common endpoint called the vertex. The rays are the sides of the angle. Notice that the vertex is the corner, what you consider the corner. The rays and angles are always made up by rays. So when they ask you for the sides of the angle, never answer with a segment, always answer with a ray, because angles are made up of rays. The sides are rays. Notice the angle has an interior part, it has an exterior part, and then the angle itself, which is made up by the rays and the common endpoint known as the vertex. Okay, so remember that. So if there is a point up here, this point would be in the interior of this angle right over here, because remember, the rays go on forever. So therefore, as these rays extend, all of this right here will be in the interior of this angle. Everything behind the angle will be in the exterior of the angle. And everything that is either on the side or the vertex itself, then that's the angle. Now we need to know how to name the angle, right? In this case, notice the picture. We could name the angle by its vertex. So whatever point is the vertex, we could name the angle by it. We could call this angle A. So angle A is a good name for this angle. Also, if there is a number inside that angle, we use that number to name the angle. So to be fast, this is angle 1. Okay, angle 1. The other way we name the angle, and usually we use this when more than one angle share the same vertex, we can't be ambiguous. We want to be precise. So therefore, we would name this angle BAC. So angle BAC, or angle CAB. What I want you to notice is the vertex right there. It's always in the center. So the vertex always in the center. Always in the center. So you might want to jot that down. And that's how we name angles. The next thing we want to know is how we measure angles, right? Well, how we measure. Well, basically, we're going to go over the protractor postulate. Right here, what you see is a protractor. That's how we measure. This is a tool that we use to measure angles. This is called a protractor. Notice the protractor has an outer scale that goes from 0 to 180 degrees, and then an inner scale that goes from 180 to 0. The reason you have that inner scale is because if you're reading the angle, if the angle is opening towards the left, then you want to use the inner scale. If the angle is opening towards the right, then you want to use the outer scale. Basically, that's the reason there are those two scales there. Now, let's read this through. Consider line OB. Remember, this is line OB. The line will go and keep going this way forever. So consider this line and a point A on one side of line OB. So here is point A, which is on the upper side of the line. The rays of the form ray OA which goes this way forever, can be matched 1-to-1 with the real numbers from 0 to 180. The measure of angle AOB, which is this angle right here, right? This angle, which can be written as the M of angle AOB. This M means the measurement of angle AOB. It's equal to the absolute value of the difference between the real numbers matched with ray OA and ray OB on a protractor. So basically, in this case, notice this one is 0. This one is at 0 using the inner scale, and it's opening to the left. See how OA opens to the left. Notice in the inner scale, OA measures at 140 degrees. So 0 all the way to 140 degrees. So basically, this angle measures 140 degrees. And the reason they say this, the absolute value, is because if you take the difference of 140 minus 0, that's 140, and the absolute value of 140 is still 140, so that is 140 degrees. Now, we're going to be able to use this protractor postulate later on, as we're going to be tested the different ways to do it. I will show you, I will give you examples on how to do that. Okay, here's examples. Find the measure of each angle, then classify each angle. Notice that they're asking for angle GHK, where the vertex is H. So here's my vertex, and it goes from G to H, then to K. So that means it's this angle right here, that angle right there. Let me see here. From here all the way to there. Notice this one open to the right. So it's easier, since it starts at 0, for me to use the outer scale, and notice that it goes to 125. So the measurement of angle GHK that one was easy because it started at 0, so it's just 125 minus 0, so that's 125. So that's 125 degrees. Remember, angles are measured in degrees. They're also measured in radians, but we'll cover that later. Then classify each angle. Well, this angle is more than 90 degrees. Well, this is an obtuse. An obtuse angle. Then we're given angle JHL. Well, let's erase this. And we got angle JHL. Notice this angle open from here, and it goes to the left. So it's counterclockwise, right? So JHL, notice it's a right angle. It's from 0, and I'm using the inner scale, from 0 all the way to 90 degrees. So angle JHL measures 90 degrees. So the measurement of angle JHL equals 90 degrees. So that it is a right angle. That is a right angle. So that's a right angle. Okay, so finally we had the measurement of angle LHK. Let me erase this one. LHK. So notice that LHK starts at L up here, goes down to the vertex, and then goes up back to K. So that goes from here to here, or vice versa. We don't know. Either way, it doesn't matter. If you're going to use the inner scale, you could use the inner scale, or you could use the outer scale. In this case, it does not matter. You're going to say, well, the protractor postulate says that the absolute value of the difference of the coordinates, in this case, is 90 minus, and I'm using the inner scale, that's 55. Okay, 90 minus 55. Okay, so that is the absolute value of 90 minus 55, which is 35, or the absolute value of 35. Well, the absolute value of 35 is still 35. So that means this measures 35 degrees. 35 degrees. So the measurement of angle LHK would be 35. What happens if I use the outer scale instead? Well, it'll be the absolute value of 90 minus 125. Notice that that will give me the absolute value of negative 35, which in this case, remember, absolute value puts it out positive, so that would be 35 degrees. Either way, either scale you use, it will still give you the exact same measurement. So the measurement of angle LHK equals 35 degrees. Well, okay, now here we are learning how to read and write and use basically the language of geometry, right? In here, the measurement of angle DOG is referring how much is the measurement in degrees, right? So in this case, the measurement of angle DOG is 52 degrees. However, when it's talking about angle DOG, it's just referring to angle DOG. So angle DOG is equal to angle DOG. Okay, so there is a difference when it's talking about measurement and when it's talking about the angles. Angles, the only way that the angles are equal if it's the same angle. But there is a difference between equal and congruent. We went over that difference in a previous lesson when we were talking about segments. Now we're going to be talking about angles. Okay? Okay, let's say that we say the measurement of angle A right here equals 70 degrees. Well, I could say that the measurement of angle BCA, remember, the vertex is always in the middle. Look, BCA. So the vertex is C. So this angle is also 70 degrees. Then since they're both 70 degrees, I could say that the measurement of angle A is equal to the measurement of angle BCA. I could say that because we're talking about the measure. Okay, so this one measures 70 degrees and this one also measures 70 degrees. So notice that the measurement of angle A is equal to the measurement of angle BCA. And since we're talking about measurements, then we could say that they are equal to each other. However, when we're talking about, we're going to say angle 1, see, triangle ABC is isosceles. I don't know if you have heard that before, but isosceles means that you have at least two congruent sides. So I'm going to say that these two sides are congruent. So that means if these two sides are congruent, the measurement of angle 1 is congruent to the measurement of angle 2. Actually, they meant to put the measurement, or angle 1 is congruent to angle 2. It actually doesn't say the measurement. It says angle 1 is congruent to angle 2. I'm going to say that angle A is congruent to angle C. If that is true, that means I put a little arc and a little arc. Notice there's one arc and one arc. This means that these two angles are congruent to each other. These tick marks, we learned that before from a previous lessons, means that segment AB is congruent to segment BC. Okay, here we go. Estimating measurements of angles and then actually measuring the angle using a protractor. Okay, when we are going to estimate, if I'm going to estimate, remember, estimate doesn't mean that you have to be exact. It means you're estimating certain number with a margin of error. Now, if your margin of error is about 10 degrees, that should be good. But if your margin of error is about 40 degrees, well, that's way off. See what I'm saying? So the way I do it is I usually want to start from imagining. I take one of these and I say, well, if I am going to say, I'm going to say a 90-degree angle would be about there, right? So that would be like a 90-degree angle right there. So if you look at this, this should be, it's almost about half. So if it's about half of 90, I would estimate this to be anywhere from 45 to 47 degrees. I'm gonna say it is just 45 degrees. That's about 45 degrees, estimating it, right? That's estimating it. If I was to do this one, I would say in estimation, I would just draw like a approximately, right? Approximately, that's a 90 degrees right there. So here we got a 90, about 10, 12 more. So I would say this is about 102, 103 degrees. I'm gonna say this angle right here is about 103 degrees approximately, just to hit it in between, you know, not to be off by so much. I know it's not exact, but hey, it should be close enough. Now we're gonna go ahead and measure. When we're measuring using a protractor, let me grab the tool. Right here we have a protractor. Notice the vertex would go right at this point right here. So I am going to put the vertex, which is this one right here, at this point, and I'm gonna zero it out, right? I'm gonna zero it out. Let me see how I move this. There we go. So there is 0. Notice that I am pretty close. If this is my vertex, I am right there, 44 degrees. I said 45, so I am off maybe by half of a degree, if that. So that's pretty good. That's a good estimate. You see, that was right on, because it's easy to see that that was like half of 90. If I'm going to go to this one and estimate it, I estimated at 103. Well, let's see. First of all, I zero it. Notice now it's at 0 here. And that is about 90, is almost where I put it. And then I'm using now the other scale. You see that, because it's opening clockwise. So that's 100, 105. So it's 105. I put 103. So we are off by what? By 2 degrees. So that's pretty good. And that's basically how you estimate. You want to start from a known fact. The known fact is I know where my 90 degree is. So if I know where my 90 degree is, then I could estimate where the rest is. You know, where would the line approximately be at in the scale of the protractor. All right, so now let's look at acute angles. Let's classify angles. Acute angles. What is an acute angle? That is an angle that measures between 0 and 90 degrees. So it's an angle that measures between 0 and 90 degrees. So X, the angle X, right? Whatever the measurement of that angle is, say the measurement is X, is between 0 and 90 degrees. Okay, a right angle is an angle that is exactly exactly 90 degrees. So if that angle is equal to 90 degrees, then that is a right angle, okay? And 90 degrees, when two lines intersect and they're perpendicular, just so we learn that, perpendicular. That means that it measures 90 degrees. That means that it measures. The symbol for perpendicular is a T upside down, okay? When you see this symbol right here, that means perpendicular. Learn this because this is important, okay? An obtuse angle. An obtuse angle is an angle that measures between between 90 and 180 degrees. So it's more than 90, less than 180, okay? And that is, so X is between 90 and 180. If that is true, then you have an obtuse angle. Then the other one is a straight angle. The straight angle is basically a line. It's called a straight line, right? Which are opposite rays. These are opposite rays. Let's put it because we already learned what opposite rays were. Opposite. They have a common vertex, right? And from there, they go in opposite directions. It's an angle. That measures exactly 180 degrees. Okay, 180 degrees. That's an angle that measures exactly 180 degrees. So if X, meaning the angle, equals 180 degrees, then you have a straight angle. Okay, one more thing we need to learn about angles is the angle addition postulate. The angle addition postulate said that if P, or point P right here, it's inside or in the interior of angle RST, then the measure of RST equals to the sum of the measure of angle RSP plus angle PST. In other words, if P being in the interior of angle RST, then we could say that this is formed right here, the angle RSP plus angle PST would make up the measurement of angle RST. Pretty simple, okay? Pretty simple. So that's something that we need to use and we're going to be using throughout the year. Okay, let's learn how to read diagrams and what all these marks mean. Remember that the arches mean that if I have two arches and two arches means that those two angles are congruent. Here they're given angle CBJ, so I look for angle CBJ. B being the vertex, remember B is the vertex, so C, here let me highlight it so you see how I read it. Angle CBJ. You could see the angle. The angle is right here where the vertex is B. Notice it's not ambiguous. If I wouldn't name this angle B, we would not know which angle we're talking about because B is the vertex of many angles. For example, here's another angle who has vertex as B, JBA or CBA. See? So in other words, since there are many angles for vertex with vertex B, then I want to be precise, not ambiguous. Ambiguous. Let me write that word for you. Vocabulary. Ambiguous. Ambiguous. Is that how you write it? Let me see. Ambiguous. Yeah, ambiguous. 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 If you're ambiguous, that means that you're not precise. You are not precise. That's what that means. Ambiguous means not precise. You're not being precise if you're being ambiguous. Okay, so in this case, which one is congruent to angle CBJ? Well, angle CBJ, notice it has two arches, so I'm going to look for two arches. Here it is. So I'm going to call that angle G. I'm going to start here. Angles G, H. Notice I could say F or D. It does not matter which of these two I use. Okay, I could use F or D. It's still the same angle. So angle G, H, F or angle G, H, D. So I'm going to write that. Angle G. The vertex is H and it goes through F or D. So I'm going to just write F. Okay. Angles G, H, F. If you put angle G, HD. It's correct, okay? Then we're saying angle FJH, angle FJH. Let me erase these so that we see what we're talking about. So I'm gonna go to angle, I'm gonna go yellow this time, FJH. So FJH, so FJH. Notice this angle FJH, that has 1, 2, 3 arches, and here are 3 arches, okay? So 3 arcs, 3 arcs. So I would say angle AJB. So angle A, J, and B. Those two angles right there are congruent. Angles A, J, B. Notice it has 3 arcs, okay? Now, if the measurement of angle EFD right there is 75 degrees, that's right, erase that. If the measurement of angle EFD right there, EF, right there. If the measurement is 75 degrees, then what is the measurement of angle JAB? Angle JAB, which is down here, JAB, that would be also 75 because these two angles are congruent. See how there is one arc and there is one arc here? That means they are congruent. That means the measurement must be the same. The definition of congruency. Same measurement, same size, same shape. So it's 75 degrees right here. All right. Another questions here is if the measurement of angle GHF, so I'm gonna look for GHF, that angle right here, which is the one that I had before, right? GHF is 130 degrees, then the measurement of angle JBC, notice it's the same one as this one backwards, JBC, right? JBC. So those two angles, they have two arcs, okay? So that's also 130 degrees because they are congruent. Pretty simple, huh? And then we have the definition of angle bisector. What is an angle bisector? Well, do you remember what a segment bisector was? A segment bisector is that it could be a point, it could be a ray, a line, or a segment that intersects the segment at its midpoint, cutting the segment basically in half. Remember that? Well, a segment, ray, or line that divides an angle into two congruent angles. Let's write that down, into two congruent angles. Yep. Into two congruent. Oops. Into two congruents. Congruent. Sorry about that. In other words, it cuts it in half. That means that is an angle bisector. In other words, ray KE is the angle bisector of angle K. So we're calling this one angle K, and we drew the ray KE, which cuts the angle in half. So that makes this one right here congruent to this one right here. So if it's the angle bisector, then these two halves are, the measurement are equal to each other, okay? The measurement is equal to each other. So let's go over some examples. All right, so it's given. Ray AT is the angle bisector of angle MAH. Notice angle MAH. That's your angle. it's being cut into two congruent angles, which are this angle right here, MAT, and TAH. These two angles are congruent because this one is the angle bisector. Given that the measurement of angle MAT right here is 60 degrees, and given that the measurement of TAH is 4x plus 20, it says find x. Well, basically, if these two angles are congruent, then we could say that the measurement of angle MAT is equal to the measurement of angle TAH. If I use substitution, then I could say for the measurement of angle MAT, we have that is 60 degrees, is equal for x plus 20. Well, 60 minus 20, that's 40, equals 4x. 40 divided by 4, that means 10, is x, so x must equal 10. And that would be my answer. That would be my answer. Pretty simple, right? Look at this one. It says, given angle LOB. Notice there's no measurement. It's now we're talking about congruency. Angle LOB is congruent to angle VOE. VOE. So now we could say, well, this angle right here is congruent to this angle right here. If these two angles are congruent, that means that ray OB is the angle bisector. Because notice these two are congruent. So by definition, well, that means that then that's the angle bisector. The measurement of LOB is 7x minus 14. So I'm going to write that here, 7x minus 14 on LOB right here. 7x, let me write it here, 7x minus 14. Therefore, let's say that the measurement of VOE is 3x plus 12. Let's call this 3x plus 12. So the measurement of VOE is 3x plus 12. Okay, find x. So we already know that the measurement of these two, because these two are congruent, LOB, angle LOB and angle VOE are congruent, then the measurement of angle LOB, let's write that down. The measurement of angle LOB must be equal to the measurement of angle VOE. Notice I write my geometric equation first. Now I substitute for the measurement of LOB. We have 7x minus 14. 7x minus 14 must be equal to 3x plus 12. In this case, notice this is positive here. If I put it on this side, it will become negative, right? So 7x minus 3x is the same. This one is negative 14. So when I cross the equal sign, it will be positive 14. 14 plus 12. So 7x minus 3x, that is 4x. 14 plus 12, that's 4 and 2, that's 6, that's 26. 26. All I have to do now is x is 26 divided by 4. 26 divided by 4. Okay, if you want to turn this into a decimal, all you have to do is divide it. So 26 divided by 4. Well, 4 times what? Times 6. 6 times 4 is 24. 6 minus 4 is 2. That's 20. There's a point here, right? Because I'm lowering this 0 down right there. So 20 divided by 4 is 5. So that's 6.5. So x is approximately or equals to 6.5. So now what does it say? Find the measurement of angle LOB. Well, the measurement of angle LOB, which is 7x minus 14, right? 7x minus 14. So we could say, well, the measurement of angle LOB equals 7x minus 14. So we found x already. Now we're going to plug it in. Equals 7 times 6.5 minus 14. 7 times 6.5. Let's look for the calculator here. 7 times 6.5 equals 45.5. So that equals 45.5 minus 14, which is equal, and go back to the calculator, put minus 14. Oops, delete that. Minus 14. Enter. So that 31.5 or 31 and 5/10. So 31.5. So the measurement of angle LOB equals 31.5 degrees. And that would be the answer for that bottom part right there. Pretty simple. Well, that concludes the lesson for this section. Go ahead and get some protractors. I have some in the room, so you could borrow mine if you don't have your own. And let's start practicing. Let's start practicing and become more knowledgeable. Perfect. Okay? See ya.